Alright, let's talk about something most of us use every single day, but probably don't think much about. I'm talking about oil and gas. It's the stuff that fuels our cars, heats our homes, and makes the modern world go round. We just flip a switch or turn a key and it's there. But have you ever stopped to wonder how it gets from deep inside the earth to your gas tank or your furnace? It's not magic, I can tell you that. It's a story of incredible engineering, heavy-duty machinery, and some of the hardest working people you'll ever meet. It's a dirty job, but a fundamentally important one that powers our entire way of life. The journey of this energy is a long and complicated one, full of challenges that would make most people throw in the towel. It starts miles beneath our feet, locked away in ancient rock formations. Getting it out isn't as simple as sticking a giant straw into the ground and sipping. It requires a deep understanding of geology, physics, and mechanics. It's a high-stakes game against immense pressure, extreme temperatures, and the unforgiving forces of nature. The people who do this work are problem solvers of the highest order, figuring out how to pull these resources from the planet's grip safely and efficiently, day in and day out. This whole process, this monumental effort, is what the industry calls production. It's the heart and soul of the oil and gas business. It's the part of the story where potential energy becomes actual power. And at the center of it all is the equipment, the tools of the trade. These aren't your average workshop tools. We're talking about massive, complex machines designed to operate in some of the most hostile environments imaginable. From the depths of the ocean to the scorching heat of the desert, this gear has to perform flawlessly. Because if it doesn't, the consequences can be enormous. So stick with me. We're going to pull back the curtain on this fascinating world. We'll look at the nuts and bolts, literally, of how we get oil and gas out of the ground. We'll talk about the different kinds of equipment, why one piece is chosen over another, and how it all fits together in this giant, powerful puzzle. It's a world that's often out of sight and out of mind, but it's a world that affects every single one of us. Understanding it is the first step to appreciating the incredible work that goes into keeping our lights on and our engines running. So, what exactly do we mean when we say production in the oil and gas world? Simply put, production is the phase where we actually bring the oil and gas to the surface. Think of it like this. Exploration and drilling are like finding the treasure and digging the hole to get to the chest. Production is the job of opening that chest and carefully lifting the treasure out day after day, for years or even decades. It's the long-term, marathon part of the operation. It's about managing the flow of hydrocarbons from the reservoir, through the well, and into the pipelines that start their journey to a refinery. This isn't a one-and-done deal. A reservoir, which is just a fancy word for an underground pool of oil and gas trapped in porous rock, has its own life cycle. When a well is first drilled, the natural pressure in the reservoir might be high enough to push the oil and gas to the surface on its own. This is the easy part, the free flow stage. But that natural pressure doesn't last forever. As you pull more out, the pressure drops and the flow slows down. This is where the real work begins, and it's where the pros separate themselves from the amateurs. Production is the art and science of keeping that flow going. The production phase involves a whole system of interconnected equipment, both below the ground and on the surface. Imagine a complex plumbing system stretching for miles, all designed to control a highly pressurized, often corrosive and flammable substance. Below the surface, you have tools and pipes that make up the completion, which is the interface between the well and the reservoir rock. Above ground, you have a collection of valves, separators, and tanks known as the surface facilities. Every single piece has a specific job, and they all have to work together perfectly to manage the pressure, separate the oil, gas, and water, and prepare the products for transport. List: Media Group, Technician Adjusting Pressure Valve, Pressure Management System at Oil Facility at Stock it at Distribute _equally. Manage the pressure, separate the oil, gas, and water, prepare the products for transport. Ultimately, production is about maximizing the recovery of resources from a reservoir safely and economically. It's a constant balancing act. You want to get as much oil and gas out as you possibly can, but you have to do it without damaging the reservoir, the equipment, or the environment. List: Media Group, Reservoir Protection Measures in Oil Field, Environmental Safeguards at Oil Site at Stock at Distribute _equally, without damaging the reservoir, the equipment, or the environment. It requires constant monitoring, maintenance, and adjustment. List: Media Group. Oil field technician inspecting equipment, workers performing routine maintenance, stock distribute equally monitoring maintenance adjustment. It's a dynamic process where engineers and field operators are always making decisions to optimize the system. It's the critical, long-running operation that turns a discovery into a reliable source of energy for the world. Let's go underground. Miles beneath the surface, in the dark and under crushing pressure, is where the real magic of production begins. This is the domain of subsurface equipment, the stuff you never see but can't live without. These tools form the well completion, which is essentially the highway for oil and gas to travel from the reservoir rock into the well bore. The first line of defense and offense is the casing and tubing. Casing is a large diameter pipe that lines the drilled hole to provide structural integrity and prevent the well from collapsing. Inside that, you run a smaller pipe called tubing, which is the dedicated conduit for the oil and gas to flow up to the surface. But it's not just about pipes. To control the flow from the reservoir into the well, you need specialized tools. One of the most important is the packer. A packer is a device that creates a seal in the space between the tubing and the casing. Why is this so important? It forces the oil and gas to flow up through the tubing, not up the sides, giving you complete control. It also protects the casing from the corrosive fluids and high pressures coming from the reservoir. Think of it as a high-tech cork that directs traffic and protects the infrastructure of your well. It's a simple concept, but a critical piece of the puzzle for a safe and efficient operation. Then you have the perforating guns. After the well is cased, you basically have a steel-lined hole, but the oil and gas are still trapped in the rock outside that steel. So, how do you connect the two? You lower these perforating guns, which are essentially explosive charges, down to the target zone. When they're fired, they blast holes through the casing, the cement, and into the reservoir rock, creating channels for the hydrocarbons to flow into the well. It sounds violent, and it is, but it's a precisely controlled process that opens the floodgates and brings the well to life. It's the job that officially turns a hole in the ground into a producing asset. Finally, downhole, you also have a variety of safety and control valves. A subsurface safety valve is a fail-safe device located in the tubing string, often hundreds of feet below the surface. Its job is to automatically shut off the flow of oil and gas in an emergency, like if there's damage to the wellhead equipment on the surface. These unseen heroes, the packers, the perforations, the safety valves, are the foundation of a productive well. They are the tough, reliable tools working in the harshest conditions to ensure that the resources are recovered safely and effectively, without anyone on the surface ever having to see them in action. Once the oil and gas travel up the well, their journey is far from over. They emerge at the surface and are met by a maze of pipes, valves, and vessels known as the surface production equipment. The first thing they encounter is the wellhead, which is the termination point of the well at the surface. It's a large, heavy assembly of spools and valves that provides a secure pressure seal and allows you to control the flow and access the well for maintenance. Sitting on top of the wellhead is the Christmas tree, an assembly of valves, chokes, and gauges used to control the flow of oil and gas out of the well. It's called a Christmas tree because of its crude resemblance to a decorated tree. But its job is all business. From the Christmas tree, the real work of processing begins. The fluid coming out of the ground is rarely just pure oil or pure gas. It's usually a high-pressure mixture of crude oil, natural gas, water, sand, and other impurities. You can't just pump that mix into a pipeline. You have to separate it. This is the job of the separator, a large pressurized vessel that uses gravity and other principles to split the fluid stream into its primary components. Oil, being heavier than gas but lighter than water, settles in the middle, while gas rises to the top and water sinks to the bottom. Each component is then piped out separately for further treatment. After the initial separation, each stream needs more work. The oil might go to a heater treater to help break up any remaining water emulsions and further purify it to meet pipeline quality standards. The natural gas, which is still saturated with water vapor, is sent to a dehydration unit. This unit uses chemicals or refrigeration to remove the water, which is crucial because water can form ice-like structures called hydrates that can plug up pipelines, especially in cold weather. The produced water, which is often very salty and may contain traces of oil, must be treated properly before it can be disposed of or re-injected back into a reservoir to help maintain pressure. All of this equipment, the wellhead, the separators, the treaters, the dehydrators, forms a complex surface facility that acts like a mini refinery right at the well site. Its job is to take the raw, messy fluid from the reservoir and transform it into clean, market-ready streams of oil and gas. It's a system that requires constant monitoring and control to handle changing flow rates and compositions from the well. This is where the raw power from below the ground is tamed, processed, and prepared for its final journey to consumers. It's a vital and often noisy part of the production process. In a perfect world, every oil well would have enough natural pressure to push oil to the surface for its entire life. But, we don't live in a perfect world. As I mentioned earlier, that natural drive eventually fades, and the flow of oil slows to a trickle or, stops altogether. When that happens, you don't just abandon the well. There's still plenty of valuable oil down there. You just need to give it a little help. This is where artificial lift comes in. It's really a broad term for any method used to lift oil to the surface when the reservoir pressure is no longer strong enough to do it on its own. Honestly, it's the workhorse of the oil field. One of the most iconic pieces of equipment in the oil patch is the sucker rod pump, also known as a pump jack. You've seen them, those big bobbing horse heads slowly nodding up and down in fields all over the world. It's a pretty simple and, I have to say, brilliant design. The nodding beam on the surface drives a long string of steel rods, the sucker rods, up and down inside the well's tubing. At the bottom of this rod string is a pump that works just like a syringe, drawing oil into the pump on the upstroke and pushing it up the tubing on the downstroke. It's old-school technology, but it's reliable, effective, and it gets the job done in many onshore wells. Another common method is the electric submersible pump, or ESP. This is a more high-tech solution. An ESP is essentially a long, skinny, multi-stage centrifugal pump connected to a sealed electric motor, and the entire assembly is lowered deep into the well, submerged in the oil. When it's switched on, the spinning impellers of the pump drive the oil with great force up the tubing. ESPs are powerful and can move huge volumes of fluid, making them ideal for wells with high production rates. They are more complex and expensive than pump jacks, but for the right application, they're absolutely the best tool for the job. There are other methods too, like gas lift, where you inject high-pressure gas down the casing of the well. This gas enters the tubing at the bottom, mixes with the oil, and lowers the overall density of the fluid column. This lightened column is then easier for the remaining reservoir pressure to lift to the surface. Each artificial lift system has its own strengths, weaknesses, and operating costs. Choosing the right one depends on factors like how deep the well is, how much fluid it produces, and the properties of the oil itself. It's a critical decision that can determine the profitability of a well for years to come. Now, getting the oil and gas moving is one thing. Keeping it moving is a whole other battle. This is the world of flow assurance, which is a fancy term for making sure the hydrocarbons can flow smoothly from the reservoir all the way to the processing facility without any blockages. It's kind of like being a plumber for the world's most expensive and complicated plumbing system. The things that can go wrong down in a pipe that's miles long and just a few inches wide are enough to keep engineers up at night. These problems can actually shut down production, cost a fortune to fix, and in some cases, cause some pretty serious safety issues. One of the biggest enemies of flow assurance is something called hydrates. These are ice-like solid crystals that form when natural gas and water mix at low temperatures and high pressures, conditions that are, honestly, very common in deep-water pipelines. Hydrates can build up and form a solid plug that completely blocks the pipeline, effectively choking off production. To prevent this, engineers might insulate the pipelines to keep the fluid warm, or they might continuously inject chemicals like methanol or glycol, which act like antifreeze for the gas, preventing these ice plugs from ever forming in the first place. Another nasty problem is wax and asphaltenes. Some crude oils are naturally waxy. As the oil travels up the well and through pipelines, it cools down. If it cools below a certain temperature, known as the wax appearance temperature, the wax will start to solidify and deposit on the inner walls of the pipe. Over time, this buildup can restrict the flow, just like cholesterol clogging an artery. To combat this, companies might use heated or insulated pipelines, send a mechanical scraper called a pig down the line to clean out the wax, or inject chemicals that prevent the wax crystals from sticking to the pipe wall. Finally, you have to worry about corrosion and scale. The water produced with oil and gas is often extremely salty and can contain corrosive gases like carbon dioxide and hydrogen sulfide. This can literally eat away at the steel pipes from the inside out, leading to leaks and failures. At the same time, changes in pressure and temperature can cause minerals dissolved in the water to precipitate out and form a hard rock-like deposit called scale on the inside of the pipe. Both of these issues are managed with a steady diet of specialized corrosion and scale inhibitor chemicals, which are injected into the fluid stream to protect the integrity of the entire production system. So, with all this incredible equipment out there, how do you decide what to use? You don't just pick the biggest, shiniest pump or the most expensive valve. The selection process is actually a careful balancing act between two major forces: technical requirements and economic realities. It's a decision that can really make or break the profitability of a project. A wrong choice can lead to poor performance, frequent failures, and sky-high operating costs. But a right choice ensures that you can recover the oil and gas safely, efficiently, and most importantly, profitably for many years. It's a blend of hard science and smart business. First, let's look at the technical side. Engineers have to consider a mountain of data. What are the properties of the reservoir fluid? Is the oil light or heavy, waxy or sandy? How much water and gas will be produced alongside it? What are the pressures and temperatures downhole and on the surface? How deep is the well? Is it on shore or in the deep ocean? All of these factors will dictate what kind of equipment can even handle the job. For example, you wouldn't use a standard pump jack in a well that's 2 miles under the sea, and you wouldn't use materials that corrode easily in a well that produces sour gas. The physics and chemistry of the situation create a set of non-negotiable technical constraints. But technical feasibility is only half the story. You can have the most technologically advanced solution in the world, but if it costs more than the oil you'll get out of the well is worth, it's a non-starter. This is where the economics come in. Every piece of equipment has a price tag, not just to buy it. This is called capital expenditure, or CAPEX, but also to run and maintain it over its life, which is called operating expenditure, or OPEX. A cheap pump that breaks down every month will end up costing you more in lost production and repair bills than a more expensive, reliable one. The goal is to find the sweet spot, the solution that meets all the technical requirements for the lowest total life cycle cost. This involves running complex economic models that forecast production rates, oil prices, operating costs, and maintenance schedules over decades. It's about asking questions like, does it make more sense to spend more upfront on a corrosion-resistant alloy, or to use cheaper steel and plan for a chemical injection program? These are the multi-million-dollar decisions that equipment selection engineers have to make. It's a high-stakes game of trade-offs, where getting it right means a successful project and getting it wrong can be a financial disaster. Now, I've just given you a quick tour of a massive and complex industry. We've scratched the surface of production, looked at some of the gear, and talked about how it's chosen. But if you really want to understand how this world works, you have to go deeper. Reading about it is one thing. Seeing it in action and learning from the experts is another. This is where Insight Global Training Academy, or IGTA International, comes in. They've built a virtual classroom portal that lets you dive headfirst into this stuff with hands-on sessions and detailed modules that bring the oil field to your screen. It's your chance to move from being a curious bystander to someone who truly gets it. Their training program is broken down into modules that cover everything we've talked about today and a whole lot more. It starts with an intro to production systems, giving you a solid foundation of the entire process from the reservoir to the refinery. Then you can dive into specialized topics. The artificial lift selection module walks you through the pros and cons of different lift methods, from pump jacks to ESPs to gas lift, and teaches you how to choose the right one for any given well. You'll learn the why behind the choice, not just the what. The training continues with deep dives into the hardware. The surface production equipment module breaks down every component of a surface facility, from wellheads and separators to treaters and dehydration units. You'll understand how they all work together to turn raw well fluid into marketable products. Similarly, the Subsurface Completion Tools module takes you downhole to explore packers, safety valves, and the art of well completions. You'll learn how these critical components ensure the safety and longevity of a well. These are the details that separate the pros from the rookies. And it doesn't stop there. An entire module is dedicated to flow assurance techniques, where you'll learn to identify and solve problems like hydrates, wax, and corrosion before they shut down in operation. Finally, the Equipment Selection Strategy and Economics module ties it all together. This is where you learn to think like a senior engineer, balancing technical performance with CAPEX and OPEX to make the most profitable decisions. It's a comprehensive curriculum designed to give you a 360-degree view of oil and gas production, taught by people who have spent their lives doing this dirty but essential work. You might be thinking, this is all very interesting, Mike, but I'm not planning on working on an oil rig. Why should I care about packers and separators? That's a fair question, and the answer is simple. Because this industry and the knowledge behind it is connected to almost everything. Whether you're an aspiring engineer, a finance professional, a project manager, a salesperson, or even just a curious student trying to figure out your path, understanding the fundamentals of the world's primary energy source gives you a massive advantage. It provides context for how the global economy works. For those looking to enter the energy sector, this kind of training is a no-brainer. It gives you the vocabulary and the foundational knowledge to hit the ground running. You'll be able to have intelligent conversations with geologists, engineers, and field operators. You won't be the person in the meeting who gets lost when the conversation turns to ESPs or hydrate inhibitors. This knowledge from IGTA International can be the key that unlocks career opportunities, whether you're aiming for a technical role on a platform or a corporate role in a downtown office tower. It shows you're serious and that you've done your homework. But this isn't just for future oil and gas workers. If you're in finance, understanding the CAPEX and OPEX of production helps you build better investment models. If you're in sales, knowing the technical challenges your customers face allows you to sell solutions, not just products. If you're a project manager, understanding the equipment, lead times, and installation complexities is critical for building realistic timelines. This knowledge transcends job titles. It's about understanding a core industrial process that drives markets, geopolitics, and technological innovation. It makes you a more well-rounded and valuable professional, no matter your field. So whether you're a student picking a major, a professional looking to switch careers, or someone already in the industry wanting to broaden your horizons, this is your shot. This is about more than just learning about machines. It's about appreciating the ingenuity and hard work that powers our world. It's about understanding a dirty job that is absolutely fundamental to our way of life. Taking the time to learn this stuff is an investment in yourself. It's a way to get a leg up, to see the bigger picture, and to understand one of the most important jobs on the planet. And in my book,